Now, what happens when we multiply two numbers together that happen to be exponents of the same base? So that may sound quite complicated, but let's break it down a little bit. So let's say that we're multiplying 2 to the power 3 times 2 to the power 4. Now, both of these numbers are exponents of the same base, which is 2. And that's important for what we're going to do next. But if we think about what we're calculating here, well, 2 to the power 3 is 2 times 2 times 2, so there's 3 2's there. And 2 to the power 4 is 2 times 2 times 2 times 2, there's 4 2's there. And all of these are multiplied together. Now, it's true that initially these multiplications are separate, but when you just multiply things together in maths, you can actually get rid of the parenthesis in this case and just say, well, we're multiplying 2 by itself 7 times. And that brings us to the general rule of how to multiply exponents of the same base. What we're doing is actually we're going from 2 to the power 3 and 2 to the power 4 to 2 to the power 7. So we're adding the exponents together. So here it may be a little bit counterintuitive. We're multiplying numbers together and we end up adding the exponents. That's just one of these rules in maths that, well, you can try and understand it via breaking it down like we did here. Or another way of dealing with it is you just learn that as a rule off by heart and make sure that you apply it in the right ways in the GMAT. Now let's look at what happens when we divide two exponents of the same base. So let's say that we want to divide 2 to the power 5 by 2 to the power 3. Notice that it's the same base, so in both cases the number at the bottom is 2, and that's important because otherwise this rule does not apply. If we think about what's happening, so at the top we've got 2 to the power 5, which is 2 times itself 5 times. And at the bottom we've got something similar happening, except that we've only got 3 2's. Now, if we were to make this calculation, what we can see is actually a lot of these 2's are going to be, well, we can just cancel them out because we're multiplying by 2 and then dividing by 2, and so we can just avoid that by crossing them out like this, and then effectively we've only got 2 times 2 at the top left. So another way of thinking about that is 2 to the power 5 divided by 2 to the power 3. It's equal to 2 times 2, or 2 to the power of 2. But we can also see that what we're doing is we're subtracting the exponents, right? So this power 3 at the bottom, effectively what it becomes is a negative 3 when brought back to the top. And therefore we subtract one from the other to get 2. Let's look at a slightly more complicated example that involves more than one base. So in this case, we've got at the top powers of 3 and 7, and at the bottom we've got powers of 3 and 7 and 21. Well, first of all, let's look at the 21 squared. So 21 is 3 times 7. And we can effectively distribute that power of 2 onto the 3 and the 7. So that's equal to 3 squared times 7 squared. And now we've got a fraction with just 3's and 7's in it in terms of bases. So what we can do is we can regroup those 3's and 7's together using the rules that we've seen. So in this case, at the top, we've got 3 to the power 3 times 3 to the power 6. We can combine that into 6 plus 3 equals 9. And we can also combine the 3's at the bottom and the 7's at the bottom. So the 3 to the power of 2 times 3 to the power of 2 we can combine that into 2 plus 2, 4 of them. And the 7s, we've got 7 of them in total. Now notice that we're keeping the 3s and the 7s apart here. And that's common in the GMAT. You don't want to try and combine these different numbers together. You keep them separate, and often you'll find that the answers have, in that case, just exponents of different bases. We haven't quite finished this one, because at the end, we've got some 3s at the top and 3s at the bottom, and now we're using the dividing rule, which is to say, well, we've got 9 3s at the top, 4 at the bottom. So what we do is we do 9 minus 4 on 3s, and we do 4 minus 7 on the 7s. So we're left with 3 to the power of 5 times 7 to the power of minus 3. And that 7 to the power of minus 3, it can be written as 7 to the power of 3 at the bottom. So this example is very important for understanding how we juggle between different bases of exponents in different parts of the fraction, and how we simplify the whole thing to get to one fraction at the end with just 2 bases, in this case of 3s and 7s.